Yeah, I think it started now. Huh. Okay. So you guys know why I started we're teaching ADF, right? So along with the one data warehouse, you guys need to have at least one ETL tool. Okay. At least one. Then, so what did I do is instead of like teaching other tools and all, intentionally I'm teaching here ADF. Intentionally. So I told you already, I'm pulling your legs into Azure cloud intentionally. Okay, because see, Snowflake with Azure combination might not be good. It's good actually, but people think that okay, it's not good combination. Yes, I agree with them. The combination is not good, but you need to have at least one cloud knowledge, at least one ETL tool knowledge. Then you'll get calls actually on Snowflake. Okay, for that I started actually teaching ADF. Okay, so that is only the reason. I used to teach Matillion, but I thought, okay, Matillion is not a, that is an independent ETL tool, I can say. Then you will not get into cloud until I pull your leg. Until unless you get the requirement in the real time, you will not get into that cloud. So I thought, okay, I can start teaching ADF. At least they'll come to know the cloud basics, and at least they'll come to know the ETL of the cloud. So ADF is a ETL tool of the Microsoft Azure. Okay. Now, so the full form of ADF is Azure Data Factory. Before I get into the tool basics and all, please do not scribble my screen, please. I don't know who is doing that. Just go on mute and listen. Concentrate. That's it. Ah. So before I get into that ADF, I would like to tell you the basics or fundamentals of the Azure. Many people doesn't know what is data center, why cloud came into picture, and how the things are going in the back end, cloud back end. They do not know all those things. Okay, so I wanted to give that one. So it will take some time to understand. See, I don't need to explain all these things, but you guys know, like we start everything from scratch. So we always believe that fundamentals are more important. Okay, do not think that I'm teaching a junk topic, junk stuff here. Please do not think, because these fundamentals will help you a lot in Azure, like resource creation. A lot, really a lot. Okay, so do not think that. Okay, uh, I I know I'm not wasting the time. I'm clear. I'm very clear on that. Okay, okay. So what I'm trying to say here is why cloud came into the picture, why cloud came into the market, why people are satisfied before the cloud. People are using traditional IT infrastructure and they were happy at that point of time. Why all of the sudden the cloud has started spinning up the started like services. Okay. Now, previously, before the cloud, we used to have the hardware like this. We used to have in the traditional IT infrastructure, we used to have components like this. Storage, we used to have databases. Databases are nothing but, again, the servers only. So they'll take one server, they'll try to install Oracle or SQL Server, and they'll try to maintain that. And we used to have SAN switches. Switches are nothing but it is kind of a router between the servers and the storage. So they'll try to have different servers, and if at all if you want to communicate between the servers, they'll try to take here switches. See how you have LAN area network, right? LAN local LAN, right? To communicate between the systems or among the systems. In the same way, SAN we have SAN switches. Okay, so like that we used to have different components are there. Not only this one, routers are there, network is there, many things are there, but these are all the main things I would say. Okay. Now, what is the problem with the traditional IT infrastructure? What is that problem actually? Okay, now what I will do is, can I come back here? Just a second, guys.
Maintenance, patches, upgrades, and hardware upgrades. It's pain. It will put more pressure on the management to manage
Exactly.
the data center, because
Exactly.
I have near about 15 years of experience in data center. Still, I install data domains and backup storage in many of the data centers for banks in United States. I know the pain.
Yes, exactly. Okay. Since you have more experience on that one, correct me if I'm like if I say any point wrong here. Okay. See, what I would like to say here is, let's say company, let's say you take Amazon as an example, guys. Okay. During normal days, actually, during normal days, hardly, like, let's say per day they'll get 1 million orders. 1 million orders. Or Flipkart also you can take as an example. Flipkart, once in a quarter, they used to conduct big billion days. Or Amazon, they used to conduct some, what is that? Even for every quarter, they used to conduct one offer kind of thing, right? What is that Amazon one?
Big sale day, something like
Big
that.
sale day, something is there, right?
Mm.
Okay. So something like that. Okay. So at that time, let's say for maintaining, for taking up this traffic, they, let's say they have only 10 systems from their end. Only 10 systems. Okay. Now, during that big billion days or during festival days, this count is not enough, guys. 10 systems cannot able to manage that website traffic actually. They need to scale up. They need to scale the number of servers. So at that time, they may need 1,000 servers to manage the traffic, to manage that the e-commerce transactions, I can say.
For example, Black Friday.
Yeah, Black Friday is also good example. In US, actually, every year in November, they used to go, second week, I think they used to celebrate Black Friday. During that day, huge transactions will happen. Huge transactions in Amazon. Okay, so they need to place these 1,000 servers in some building actually. So that they call it as a data center. Let's say they place that they established all the 1,000 servers in a building. For that, they need to pay rent, right? They need to pay. See, this is not a cloud actually. This I'm talking about the traditional IT infrastructure. Okay, Amazon has decided to pay rent for one of the building. That's okay. This is one of the problem I can say. First problem. If any company wanted to scale their infrastructure, they need to set up all those things in a physical building. So if they have their own data center, of course they can set up everything in their own data center. If they don't have anything, they need to take rent and they need to pay rent for that building for every month. That is the first problem. Second problem is they need to maintain power supply. Okay, you guys know, right? So since they're maintaining servers right in that building, they need to make sure that there should not be a power downtime. Okay, so they have to maintain 24/7 that power supply. Okay, let's say they've taken the power supply from the government. Government. Okay, so for some reason in that area, something power shutdown happened. Now they need to arrange that secondary power supply option. They need to arrange that secondary power supply option because they are servers, right? They're servers. If they turned off for even 1 second, also, everything will be gone. They'll get loss in millions and millions. So they need to think about this secondary power supply as well, along with the primary power supply. Consider secondary power supply is nothing but your backup power supply, what inverter, I can say. Okay, as soon as the primary power supply is down, immediately they'll try to like switch to the backup power supply. That is
Generator.
inverters.
Yeah.
Yeah, generators are like inverters. Okay, so now they need to think about the power supply. And now cooling fans. You guys know that system is nothing but, okay, the server is nothing but a system, right? So inside the system, you will be having motherboards and the process and the hard disk and all, right? They're all electronic device, right? Ultimately, end of the day, eventually they are electronic devices, right? Electronic devices actually, when they're running, they dissipate some energy in the form of heat. Every electronic device, even your phone also, if you're using it continuously, it dissipates the energy in the form of heat. You'll feel that while you guys are talking continuously in the phone, you'll feel that heat actually. Okay, so for that, like what we need to maintain is we need to maintain cooling fans or ACs in the server room. If the primary cooling system is down, they need to think about the secondary cooling system as well. For everything, they need a backup, guys, because they are servers. My business is running from on those servers only. My website is hosted on those servers only. Okay, and of course, we need to maintain those servers 24/7. For that, I need a team. Okay, okay, with a lot of efforts, with a lot of money, with huge amount actually, I established those servers in a building. Now, initially, consider that, okay, I used in all my systems or servers, I used i3 processors. i3 processors. Okay, after couple of months, Intel has announced that, okay, we have upgraded, we are launching i5 processors. All of a sudden, after a couple of months, after launching i3, after a couple of months, they said like i5 processors also available. i5 processor, latest one. They run like 10 times faster than i3. Consider they've given that temptation to the people. Okay, because in industry, in organization point of view, speed is more important. So they told that, okay, i5 processors are 10 times faster than i3 processors. Then after establishing this entire data center, now Amazon has to change. Amazon has to replace their hardware. It is very, 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 very tedious task, guys. Do you think changing the hardware is so easy?
It's too expensive to the company too.
Yes. Yes, too expensive. It's not so easy actually. It requires downtime. They cannot change the hardware in all the systems in a single shot. They have to go phases wise. They need to take the permission from the higher management. If they agree for everything, they need to allocate the budget for that, and they need to upgrade that. And even after upgrading that one, we are not sure like the same like efficiency you're going to get what you got earlier. So a lot of things they need to think. Okay, and it takes time, of course. A lot of efforts are needed.
After installing
Okay,
everything, if it got failed, I mean, for example, if I is a failed model, then it becomes hectic
yeah,
for them.
hectic, of course, of course. It is a loss for them. It is a loss for them. Okay. Now scaling is limited. See, in a building, let's say my building capacity is 5 floors. I have 5 floors of building, and each floor I can set up only 500 systems. Each floor. Consider that. 5 floors means maximum I can set up actually 2,500 systems. Maximum. That's it. But what if my business is if I want to scale up my business? Let's say Amazon initially has their business only in the US. Now they have decided to expand that business across the world. Now they need more than 5,000 servers. My building is not enough actually. I have space constraint here. So that means scaling is limited if you're expanding your business. Okay, that is one of the problem with the traditional infrastructure, I can say. Now you need to hire a team, maintenance team, I can say. 24/7 they need to monitor your servers. in every like a traditional IT infrastructure, 24 by 3 shifts they are going to have actually 8-hour shift, 8 into 3, 24-hour actually. Uh, Administration team, main infra team, I can say. What they will do is initially one guy will, I mean, morning shift, one guy will monitor the health of the servers. He will hand over, he will take that reports actually, and he will hand over it to the second shift guy, and he will also monitor that server's health and everything, and the performance and all. Okay, and they need to make sure that the servers are running properly and they are performing very well. And second guy also need to hand over everything to the third guy. Like rotational wise, shift wise, they need to monitor guys, because server has to run 24/7. Okay, so I need to hire a team. I need to rotational wise. I need to form a team, and I need to ask them to monitor everything. That is pretty much required actually. Okay, that is also done. I've invested so much of amount in that one as well. After that, okay, after invested lot of amount, at some point of time, suddenly in that area, some earthquake came. Then what will happen? Everything is gone, right?
Yeah, we lose all the data
We lose all the data. We
if we
lost
don't have
everything.
second
Let's
party.
say, let's say some fire accident happened in that building. You're gone. Your business is gone. So these are the problems of the traditional infrastructure actually. Traditional IT. Okay. So now companies or organizations started thinking all these problems. Now, how to overcome all these things? Now, can we externalize all these? Externalize means, okay, some third party person can maintain all these things so that we can focus on only on our business. We don't need to think about all these problems actually. I don't need to invest all these things on all these matters actually. Now, at that time, cloud came into the picture. Okay, just a second. Now, what is cloud computing? You guys might have heard about this cloud computing terminology. Have you heard about this one? Cloud computing. Cloud computing. Cloud
Yes.
computing is nothing but, just a second, guys. Can you guys allow the other people actually? Because they are distracting my focus. Okay. Yeah. So cloud computing is nothing but serving or delivering of computing services over the internet. See, when you try to spin up a service in AWS or Azure and GCP, do you really need anything from your end? I mean, you just need an internet, that is enough, right, to spin up a virtual machine in the AWS or Azure. See, they are giving us a server. They're just delivering a service. Server is nothing but a service, actually. There. Okay, they are delivering a service over the internet. That's it. You need to connect to that particular service using the internet. From your end, nothing is required. Just an internet is more than enough to handle the things actually. That is what we call it as cloud computing. Taking the services, taking the computing services over the internet. Okay, the example for that one is your Gmail. Do you need to install anything from your end, like to access the Gmail, or only internet is enough? Only internet. That is one of the service from the Google. That's it. Gmail is one of the service. Yahoo is one of the service. Okay. Now next. So this is the architecture of the cloud computing, I can say. You just need a device to access the service, either it may be mobile or laptop or anything. Okay. So all these devices are connected to the router. Okay. That routers will go and contact the Snowflake. See, uh, I got habituated to the Snowflake terminology. Okay, sorry. So cloud actually, um, and from there you have to take the services. Okay, request will go like this, and the service will come in this direction. Actually, it's a bi-directional, I can say. Okay, that is also okay. When was this cloud came into the picture? Okay, in which year actually? In which year? The cloud concept came into the market back in 1950, guys, by IBM. Okay, so they used to have one concept called RJE, that is remote job entry. I don't know what exactly mean by this one, remote job entry. Maybe work from home concept was there at that point of time only. I'm not sure. Okay, that is what they're trying to indirectly saying that one here. Okay, so after that, after long time, 1950, after that in 2006 actually Amazon has announced, okay, we actually came up with the cloud. Amazon has announced their own cloud after a long time, maybe after more than 50 years. Okay, so in 2016, Amazon has provided first public cloud, that is AWS, in 2006. Okay, this was the first cloud, guys, in the market. First public cloud, I can say, public cloud especially. Okay, after that, after 2 years, Microsoft has announced their cloud, that is Azure, in 2008, but they actually came into the market in 2010. By that time, Amazon has already grabbed the market. They already have huge customers. By the time Azure has launched their cloud officially in the market. That is the reason why now also most of the customers are on AWS, not on Azure. Azure percentage is very less in the market. But slowly, even Azure people also started grabbing the market, because initially most of the companies actually adopted, or they took actually AWS cloud. These guys came into the market very late. Okay, okay. After that, okay, like we have different characteristics of the cloud actually. Huh. Now, whatever the service you need on demand basis, let's say I need EDF service, you can go and spin up. I need Databricks service, go and spin up. I need keyword service, go and spin up. On demand basis, whenever you need, you just need to spin up your service. See, what these guys are doing is, you don't need to maintain anything from your end. They will maintain all these servers or systems from their end. You just need to use that service from your end. That's it. See, whatever the problems I've explained right here, all those problems I can overcome here easily. How I can overcome? I'm not maintaining the systems. I'm not maintaining any system from my end for my business. I'm not going to do anything from my end actually. I'll just take this service from the cloud and I'll run my business. Okay, service means, let's say I need virtual machine from the Azure or AWS. For my business actually, let's say I need 1,000 servers. I'll spin up all 1,000 service in a cloud. That's it. In that Azure, in that VM service actually, I may take Linux operating system. I may take Windows operating system as well. That's up to you. If I feel that Linux operating system will give more performance, or is efficient for my business, then I'll go with Linux systems. If I feel that like Microsoft systems are more efficient than Microsoft operating systems are more efficient than more suitable for my requirement, my business, I'll go with Microsoft systems. See, I have the choice every time. I'll spin up directly 1,000 systems, and I'll focus only on my business now. And I'll run my I'll host my like website on those servers, on those virtual machines. I'll run my business. Okay, and I'll keep 5,000 servers in a standby mode. Remaining 4,000 servers. Okay, in peak days actually I need 5,000 servers. Let's say for regular days actually I need only 1,000 servers. I need only 1,000 servers. Remaining 4,000 servers, I'll keep it in a standby mode. I will not use them, but I'll keep them in a standby mode. Okay, whenever the traffic is increasing, I'll inform to my cloud, hey, whenever the traffic is increasing or whenever the load is more, you try to take the servers from this pool. You try to take the servers from this pool. That is what I'm going to inform. Then my cloud will try to scale the servers or scale the traffic or scale the like load auto as per the load, it will try to scale the number of servers automatically. That is the beauty with my cloud. Then I can focus only on my business or not. I don't need to focus on all the that problems of the traditional IT or not. That is the beauty. And no location constraint. If I want servers in US location, I can go and take it up. Okay, I can take, like, let's say I established my business in India as well. Then I can take the servers in India as well. Happily, I can do that. No location constraint as constraint here. Once you create a cloud account, you can use it anywhere. You can spin up the clusters from any location across the world, I can say. Okay, and backup and disaster recovery, you know what they are giving the guarantee here, cloud people are giving guarantee here. Your data or your services are 99.9999 up to 16 nines. 16 nines. Okay, so this is the like this is the this much of guarantee they are giving here. Your servers will not go down at any point of time. We are guarantee for that. We are providing that SLA, service level agreement, to you guys. Even if something goes wrong from our end, no problem, guys. We'll take care of that. We will take care of that. Okay. Now, in this case, actually, I'll go back to the traditional IT infrastructure here. I'll go back to the traditional infrastructure. Whatever I mentioned here, let's say you am I going to pay any rent for the data centers here for my if I want to run my business? Do I need to pay anything rent here? Do I need to pay anything rent?
In cloud, no.
For cloud, nothing is required. You don't need to pay any rent actually. You don't need to pay anything. Okay. So, like, okay, that is fine. Next, do I need to maintain any power supply from my end to like to run those systems or servers? No,
No.
not required. Okay. Do I need to have any maintenance team from my end to maintain
No.
all those servers and all? Not required.
No.
Do I need to upgrade the hardwares here? Cloud will take care of all those things. I don't need to think about software upgrades, hardware upgrades, power supply, cooling system. Everything is maintained by cloud providers only. Even monitoring also they will take care. You don't need to worry about that. What cloud people are saying that we will take care of all those things. You take care of your business so that you can save time. So if you're using my services for 1 minute, you pay me only for 1 minute. If you're using my services only for 1 second, you pay me only 1 second. That is what the concept we have in Snowflake also, right? Snowflake is also a cloud. If you're using compute power only for 1 second, you're paying only for 1 second. It's a second basis like a billing rate, not hourly basis, not day basis, right? That is what the cloud is. Even if you get any disasters, natural disasters and natural calamities here, you don't need to worry because cloud has given guarantee for me, for my data, for my servers, for my services, I can say. You don't need to worry about all those things. That's the beauty with the cloud. Okay, next. Just a second, guys. That is what I was trying to say here. Okay, and high available. They are giving guarantee. I told you already. Okay, more flexible at any point of time. You can spin up any number of clusters, any service you can take it. No problem at all. Okay, reduced infrastructure cost. Of course, we don't need to think about the upgrades and all here. No business downtime is required here. Okay, and higher security, of course. So cloud will take care of that security part as well. Once even in Azure also, once you upload your files into the Azure cloud, or even in Snowflake also, once you upload the data into Snowflake cloud actually, or Snowflake cloud is nothing but backend, it is Azure and AWS and GCP only. So once you upload your data backend, they are going to encrypt. Backend, they are going to encrypt it so that nobody is going to hack your data. That guarantee to us, we are not going to take those services, right? Because I'm the banking client actually. If you don't encrypt my data, what if somebody hack my data and like something happens to that customer data? Then you have to give that guarantee. Then only I can go and happily store my data in your cloud. So that is nothing but that is actually provided by cloud people only. Okay, this is also fine. Now you have seen all the advantages of the cloud. Okay, after that, this is what you need to understand. Based on services, based on how they are providing the services, what services they are providing. Okay, based on that, the service model is categorized into three types actually. Okay, based on what services they are providing is. Okay, now in the traditional infra, what you have to manage from your end actually, you have to maintain your application from your end. You have to maintain data from your end. That means in the server hard disk, you need to store your data. You need to maintain runtime. Runtime is nothing but Python environment or Java environment or C Sharp or .NET, whatever it is. That runtime you need to maintain. And middlewares, Oracle Fusion or some middlewares are there in the market. You need to maintain all these things from your end. Operating system also you need to maintain from your end only. These are all on-premise side actually. I'm talking. Okay, virtualization you need to maintain from your end, and servers you need to maintain from your end. Storage also you need to maintain from your end. Networking also you need to maintain from your end. Okay, now if you move on to the cloud, actually, let's say you manage the application. Let's say I'm trying to build one website actually. Okay, one application, one web application, I can say. I'm going to manage that from my end. I'll just host my application in the cloud. That's it. That means writing the code and editing that code and managing that code, everything I'm going to maintain it. Let's say backend my application generates some data. The data also I need to maintain actually. I need to tell to cloud where to store the data, how to store that data. Okay, I need to install that Python or Java or C Sharp or .NET or like Go language, whatever it is. You need to maintain that. That I need to maintain that, I can say. Okay, middlewares also I need to maintain. And operating system also I'm going to decide whether it is Linux is required, Mac is required, or Windows is required. I'm going to decide that actually. All these things I'm going to decide, I'm going to manage. Okay. And these things are actually maintained by cloud providers. What are all the things maintained by cloud providers? Virtualization. That is virtualization is nothing but replication. Okay. Servers. That means hardware. Okay. In the server, actually, storage also provided by the cloud only, and networking also maintained by cloud only. That means purely they are giving hardware to me. That's it. Like a plain hardware they are giving. I need to go ahead and install operating system in that. I need to go ahead and install Python, Java, and all there. I need to take the help of middlewares. I need to store the data in the hard disk, whatever they're providing. I need to launch my application, okay, in those servers. That means some of the application, some of the services are maintained by me. Some of the things are maintained by cloud. So that means indirectly cloud people are giving me infrastructure. That's it. Hardware. That's it. Rest all I'm going to maintain from my end. Rest all I'm going to maintain from my end. Installation and everything. So since they are providing only infrastructure or hardware to me, we call this service or we call this this one as infrastructure as a service. Only infrastructure we are taking from them. Rest all maintained by me only. So IaaS, IaaS. In short form, they call it as IaaS, IaaS. Okay. And next, okay. I don't want to maintain this operating system, middleware, and runtime. Let cloud take care of those things as well. Okay, I don't want to maintain. I don't have the time actually to install the operating system or to install the Python and the Java. So let cloud take care of that. I'll pay for that, of course. I need to pay for that, of course. See, the more the help you're taking from the cloud, the more you need to pay. That's it. Because they are saving your time, right? They're saving your manpower, I can say. They're saving your time. They're helping you to run your business. So for that, you need to pay extra, of course. So here in the second model, what I'll do is I'll take the help from cloud provider. Actually, networking I'll take from the cloud only. Storage also I'll take from the cloud only. OS also I'll take from the cloud only. Middleware also I'll take from the cloud only. Runtime also I'll take. Runtime is Python or Java and all applications, programming languages. All those things I'll take from the cloud. They will install. Even Python and Java are going to be installed by cloud only. They are readily installed in the servers. Actually, you just need to take them. That's it. They're readily available. You just need to take it. Okay. Now, once you get that like system, you need to decide how to store your data, where to store the data, and you have to maintain how to maintain your application, how to run your application. That you're going to manage, not cloud actually. You're going to simply host your application in the cloud or launch your application in the cloud. Data and all you try to maintain because this is your application, right? You have to maintain this. You know very well about the application and the data which is generated by your business. You take care of these things. Rest all will be taken care by cloud. So since they are giving here platform also, platform is nothing but operating system, middleware, runtime. Since they are giving platform also, running platform also here, so we call this model as these services as PaaS, platform as a service. Short form, people call it as a PaaS. Okay, and the last one, you don't need to manage anything from your end, guys. everything will be taken care by your cloud. Okay, example for this one is, let me tell you, Snowflake. Do I need to tell to Snowflake where to store the data? Yeah, where means like backend in which S3 bucket it has to store, how it has to, in which micro partition it has to store the data. Do I need to tell that one? Do I need to give the direction to the Snowflake people, like in the application standpoint? No, you don't need to do anything. Okay, networking, servers, operating system, data, application maintenance, everything will be taken care by your cloud only. Best example is Snowflake. I've been telling you in the class also, Snowflake is a SaaS solution. SaaS is nothing but everything is maintained by Snowflake people only. Application, Snowflake application, are you guys are maintaining? Are you guys are maintaining? Okay, are you guys are controlling where to store the data, in which S3 bucket, in which micro partition it has to store? Are you guys are controlling? Are you installing, are you running any Python or anything in your Snowflake account? No. Are you running any middleware application in the backend? No. Are you installing any operating system in your Snowflake application? No. Everything is taken care by Snowflake people only, cloud people only. You just need to create an account with the cloud and you just start using that. Nowadays, this SaaS is becoming very popular, guys. Very popular. Okay, I'll tell you one example, very good example here to understand this IaaS, PaaS, and SaaS. Okay, I don't know how far it is going to, you guys will understand this one. Let me start giving that example. Just a second. Let's say you have decided to eat pizza, guys. You got that cravings today and you have decided to eat pizza. Okay, what do you do generally? What you will do actually? Okay, you'll purchase, okay, all the raw material which is required for pizza. Okay, like cheese, toppings, tomato sauce, pizza dough, fire is nothing but like your electric oven and all. Okay, yeah, gas, soda, dining table, everything is required. That means you need to arrange all these things. Once the entire infrastructure is ready, then you can start like making your pizza. You can prepare your pizza happily. Let's say, let's say you don't have the time, guys. You don't have the time. You have decided to take the raw pizza from the retail market. Okay, let's say from Patel Brothers or from some
Costco,
other
there
retail
are
store.
Costco,
Sorry,
they have these kind of things.
raw pizza, right? They'll give.
Yeah.
Uh, so let's say you have gone to the like a Costco. They'll give you the cheese, toppings, tomato sauce, and pizza dough. They'll prepare everything actually. What you need to do is you need to get that to your home. You need to like bake it in your home actually. Okay, you have soda, you have dining table, you have electric gas. You need to bake it actually. That means few of the things are maintained or managed by you. You don't have time here to prepare that pizza, and you don't know the measurements. Of course, you're not good at cooking. Let them have all those measurements and let them prepare that raw material. We'll just take that raw material and bake it. That's it. That means few of the things are maintained by other people. Few of the things are managed by you. Okay, now you don't have time to like even bake that pizza, guys. What you will do? You you will go and order baked pizza, cooked pizza. I can say. Okay, that means cheese, toppings, tomato sauce, pizza, fire. I mean, fire or oven, electric gas, everything they are going to provide you. They are going to give you. That means they already prepared that. You just get that pizza to your home, to home, okay, and have like a soda combination with that or Pepsi combination with that, and sit on the dining table and just eat it. That's it. Because you're too busy, you don't have a time to even bake that raw pizza. They're helping here. Those guys are helping you, uh, in time saving, or they're saving your time. They're saving your effort actually here. Of course, you need to pay more, a little bit extra for that, right? For baked pizza compared to the raw pizza. Let's say raw pizza is, let's say, $1. Baked pizza is almost like $1.99. You're paying this $1 $0.99 extra because they've already prepared that actually. Just to save your time, you need to pay extra. That is what I was telling in the cloud. Okay. Of course, you don't have the time to, you don't have the dining table also, you don't have that soda also with you. Let's say previously you have dining table and soda with you. Okay, you just order that one and you just eat at your home, everything here. You don't have the dining table also. You're a bachelor, you don't have that. Then what you'll do? You'll go to the restaurant directly. You'll go to the Costco directly. You'll order there only. You'll eat there only. They are going to provide that dining table and gas, soda also. You need to pay a little bit extra. Let's say $2.5 you need to pay for that because they are providing dining table and soda also there only. So that means you're not maintaining anything here. Even you don't need to have dining table. You don't need to have prepare the soda and all here. You just go there and get it everything. This is what we call it as a like SaaS. In SaaS, you're not going to maintain anything from your end. You just need to create an account and start using the services. That's it. Okay. Did you guys get it? What I was trying to say? I don't know how clear it is for you. Guys, able to understand?
Yes, Shiva.
Yes.
Yes, Shiva.
Okay. Moving on. Now I need to give some examples for the IaaS, PaaS, and the SaaS so that you'll get better idea. Okay. So IaaS is nothing but only they are going to give only this one hardware to you. That's it. The best example for that one is VM or EC2 machines. They'll just give you hardware. Uh, mm, you need to do everything. Rest all actually. Okay. You need to install your application. You need to install that middlewares. You need to manage everything from your end. So VM is the best example for that. You just take only the hardware that's it from that. That's your wish. What do you want to install? How you want to install? What applications you want to install? That's completely your choice only. Okay, VM is the best example. In Azure, the virtual machines, I mean, the servers, we call it as a VM. In AWS, the servers, we call it as EC2 machines. EC2 machines. Okay. Now second one is PaaS. The best example for this one is database case. Database. Let's say you wanted to store some data in the cloud. Okay, for that, let's say you have taken the hardware from them, and after that you need to install that Microsoft SQL Server or the Oracle or something else, some data, Postgres, SQL and all. Here you don't need to install anything, guys. The installation part will be taken, I mean, application installation part will be taken care by cloud only. That means they'll give you the SQL environment automatically. You just need to go and store your data. You just launch that application. You just need to launch that application and store your data, because Azure SQL DB is readily available in that VM. While creating that service, you just need to mention the configuration. That's it. What type of how many servers you need, how many cores you need, like what is that backup terminology you need. All those things you just mention while creating the service. That's it. Okay. After that, you launch your application and store your data in that Azure SQL or any of the cloud. Google Cloud is also one of the example for that. Azure SQL is also one of the example, and AWS Lambda function is also one of the example for that. Okay. And the last one, SaaS, you guys know very well. Best example is Snowflake. You don't need to understand anything about that. Everything is maintained by Snowflake people only. From launching application to hardware, everything will be taken care by your Snowflake. You just need to type that URL in the browser and you start like working on the Snowflake. That's it. That's it. Okay. And even Gmail also. Are you maintaining anything from your end in the Gmail case? In the case of Gmail, nothing. You're not doing anything. You just need to type www.gmail.com, google.mail.com. You just need to start like you need to enter your username and password and start like using the Gmail. That's it. Even Snowflake also same thing. So that is the example for the SaaS. Okay. And next, what are all the different types of clouds are there? What are all the different types of clouds are there? Huh. Public cloud, private cloud, and hybrid cloud. Okay. Public cloud, private cloud, and the hybrid cloud. What is the use of this private cloud? What is the use of this hybrid cloud? What is the use of this public cloud? Private cloud is nothing but it is specific to your organization. Okay, I'll tell you one good example here. Let's say Oracle has come up with one very good solution, guys, recently. Let's say I'm the bank. I'm from the banking client actually. I wanted to store. I wanted to migrate on all my on-premise data into cloud. Okay. Since in the market public clouds are available, I don't have that guts to store my data in a public cloud. Okay, public cloud. Then I told the same point to the Oracle. Hey Oracle, I cannot store my data in your cloud because I don't believe you. I don't believe you. Okay, I don't believe your security system. But still I wanted to migrate my data into cloud. What should I do? Then Oracle people are telling that, okay, boss, you don't need to do anything from your end and you don't need to store any data in my cloud. Okay, we will come to you. We will establish that cloud kind of environment in your building, in your physical building. We will maintain everything from my end only. My team will be there. My team will maintain. My team will take care of the hardware. My team will take care of the software. My team will take care of the applications. Everything my team will take care. Okay, but you just like but you just need to provide only the physical building. You just show me some location where to store that, so that we will establish everything from our end, so that your data will not go beyond that building. You can connect to that building, you can connect to that servers happily. that acts as your own cloud. Your own cloud. How you are storing your data in a public cloud, in the same way you can store your in your private cloud. Since that is specific to your own thing here, you can happily believe that. That is what even Oracle is providing. Not only Oracle, guys, even other clouds are also providing the same kind of concept nowadays. Okay, private cloud is nothing but that is specific to that organization only. Hardware, software, networking, and the IP addresses, everything is related to, dedicated to that particular organization only. They don't store that data outside of that organization. That actually provides the greater security. Of course, that requires traditional data center staffing and maintenance. Of course, that is required. In the traditional, in the traditional IT infrastructure, in the traditional type, how we are maintaining all my infrastructure, in the same way we are going to maintain. But I'm not going to maintain that one actually. My cloud providers are going to maintain all those things. Why should I worry about from my end? Because I'm paying to them, right? But of course, they need to pay a little extra for that, since it is a private. Okay, so that is one cloud actually, one of the cloud type. Second one is public cloud. That means anybody can go and create the account. Anybody can store the data in the cloud. Anybody can store the data in the cloud. Okay, I can go and create Azure account. You guys also can go and create the Azure account. Some other person also go and create the Azure account, AWS account, GCP account as well. Okay, the infrastructure, everything is public. Public is nothing but, don't think that, okay, like everybody can go and use that one. Everybody can create an account and start using the services from them. Public is nothing but, it's not a public property. Okay, now that means here also within the public also, again we have private concept is also there. That I'll talk later. Okay, now um, uh, I can say here in the public cloud, cloud providers will try to share the hardware, will try to share the I can see infrastructure among the people. Okay, they'll try to share the data, but they'll try to share the hardware or services among the people here. Okay, so like this is not specific to the hardware, is not, or their servers or their infrastructure is not specific to particular organization. Anybody can go and use that servers. So everybody can go and create an account. Everybody can store the data. Everybody can spin up the services. That is what we call it as a public cloud. Okay, and coming to the example for this one is AWS is the public cloud, Azure is a public cloud, GCP is a public cloud. Currently in the market, these three people are the famous ones. I can say famous public clouds: AWS, Azure, and GCP. AWS is a Amazon product, Azure is a Microsoft product, GCP is a Google product. Google Cloud, Microsoft Cloud, Amazon Cloud.
How about Oracle or private cloud?
Oracle is not a public cloud, right? Oracle is a public cloud. Anybody can create the account actually there also. You can take that that also as an example. Oracle is also as an example.
It's a public cloud, but they have very less footprint, which means they have very less clients.
Yeah, of course. Of course. But actually, Oracle is
IBM also
providing
have
only Only specific kind of services I can say. See, Oracle, why Oracle has not become, why I'm not saying Oracle is a, it is a public cloud, I accept that, but they're actually specific towards their product only. They're not providing all the services, I can say. But these people are providing all kinds of services. Storage they provide, network they provide, servers they provide, CACD services they provide, and the ETL services they provide, what not, everything they are going to provide. But Oracle is not like that, right? Oracle is also a public cloud, I accept that. But Oracle is specific to their product, their certain services, I can say.
Yeah, not only Oracle, there are so many other companies like Rackspace. Rackspace is also another company. It's a public cloud, and IBM has its public cloud.
I told you point
these three
clearly.
are
Famous ones are these three.
correct. These
So
three have
many other,
good
Alibaba is
things,
also
yes.
there. That is also public cloud.
Yeah.
Like many other things are there which are not known to the people, but famous ones are these three. Okay. Yeah. Yeah. Moving on. And oh, sorry. Hybrid cloud is there, right? Okay. Hybrid cloud is nothing but for certain things they are going to take actually private cloud help. Let's say for storing the data. They're taking private cloud help. That means they have their own infrastructure for certain operations. Let's say only compute power is there or some other thing is there. Okay, for those operations actually they will use public cloud. That means they don't want to like make it fully private. They don't want to make it fully public actually. They don't want to make for certain things private, for certain things public. Okay, so that is where they are calling it as a hybrid here. It's a mix of these two, I can say. Private cloud actually the cost is more because dedicated team is required, dedicated hardware is required, dedicated network is required here. In the public cloud actually the cost is bit cheap compared to the private. Hybrid cloud the cost is, I can say, medium, I can say, compared to public and private. Okay, I cannot I don't know the example what can I give for the hybrid. Even I tried in Google as well. I did not get very good example for this. If anybody know that one, you can give that example to me. The example for the hybrid cloud. Generic example. Who are using hybrid cloud?
No, hybrid is something, some companies, so they are running different projects. They don't need to maintain everything in the cloud or everything in the on-premises. So they divide, right? Some products, some products they maintain in any of the cloud, and some of the products they maintain specifically on-premise, and they will get the direct lines from on-premises to, I mean, the direct line connection between the cloud to the online on-premises. So by the way, they achieve both.
Yeah. Okay. Okay. Yeah. Indirectly. Okay. I'll add one more point to that. But indirectly, since they're maintaining on-premise databases separately or the public cloud, and they're talking to that on-premise databases here, I can consider that as a hybrid cloud only. Yeah. Bit convinced here. Okay. But I can say but private is nothing but private cloud is nothing but I told you, right? They'll come to you, cloud people will come to you and they will establish everything in your site, right? But it may not be a the famous cloud provider. It may be your team also. Private cloud is nothing but. So I can say that okay, that is example for the hybrid cloud. Yeah, that's good one. Any other example if you wanted to give, guys? That's okay. Yeah, we can leave it. Anyway, we are not going to use that hybrid clouds much. Huh. I'll talk about this resiliency later.
Shiva,
Hmm.
the private cloud, right? What I thought as of now is so only the resources and the platform allocated to this particular company, whatever whoever go to the private cloud. So what you are saying is, so they will come and come to our location and they'll maintain everything.
Yes, correct. Correct.
Okay. But I thought that that is also will be there by.
Okay, okay. See, yeah, that is one option. One more option is if you are able to establish everything from your end, that is also private cloud only.
Yeah, we can create our own team and maintain
Our
the
own. That is also private cloud
infrastructure
only.
in our company itself.
Yes. That is also your point is correct. I mean, your assumption is also correct here.
Okay.
Then that could
Okay,
be
you can
also
establish your own and you maintain everything from your end. What's wrong in that? I mean, I've told you the example of the Oracle here. That's it.
Yeah. What I thought was. So the private cloud also will be managed by the
Public
location.
cloud people.
Everything will public cloud people only. But the
No.
resources, whatever
Yeah.
the resources they provide, right? They will not be shared. I mean, shared by other company.
Other companies outside of that company, I can say.
Okay.
Yeah. So that is about that. Next. Okay. Now I'll try to give you the high level idea, guys, today. What exactly mean by data center? Generally, people think that okay, cloud is nothing but they'll maintain all those things in the air, the cloud and all. I mean the servers and all. Okay, cloud is nothing but generally people think that okay, sorry, they'll maintain entire infrastructure in the somewhere in the sky. Okay, it's not like that actually. Okay, yeah. Before I get into that one, any questions, guys, so far? Before I start the actual day, like concepts here. Here onwards, your actual concepts will come into picture. Azure concepts. So far, I've given you the generic what is cloud and what they're going to provide and how different examples of the cloud, different examples of the service models. I've explained all those things. See, the topic that I've explained so far is applicable to all the clouds, not specific to one cloud. Okay, now I wanted to focus
See, the
only on the
private cloud, another
Azure part.
example, what we can say is even if you take the Snowflake account itself, we have different flavors like standard, enterprises, then business critical, and the last one, if you see, it's a virtual private cloud.
Virtual one, yeah, correct.
So that means
Correct.
we have that the company, whomever going for that virtual private cloud,
Hmm.
they will have a separate account. I
Infrastructure,
mean, the resources,
network,
infrastructure will
resource,
not
yeah.
be shared across any other customers within the Snowflake.
Correct. Correct. Exactly. That means they're already like public people. They will allocate separate resources for you for your business. I can say. See, I can say currently in our project also we are doing the same thing, guys. I'll tell you what we are doing is we are using actually I'm working in a banking client. My client is banking domain actually. So we are using Microsoft Azure, which is a public cloud. Now we have taken this, we have spinned up the services, ADF, Databricks, and the Azure Key Vault, all those services we have spinned up. Okay, within that ADF actually, what we are doing, we are creating PEP, that is private endpoints of the services. That means within that service, the services actually, we are creating a separate, I can say, network or separate environment. I can say, like separate IP range, subnet, I can say. Okay, we'll take the subnet, we'll create our resources within the subnet. Our services you create outside. Okay, this network will try to take from this one only, this range only. Okay, that we call it as a private endpoint. Why we are taking that one is when you try to execute your queries, backend they are going to take the public resources. Public resources are nothing but, let's say, even when you try to execute, let's say one thing, guys. Snowflake point of view, I'll try to talk here. Let's say you're running one query, select star from sales. Let's say for executing that query, backend Snowflake has pinned up actually one medium-sized cluster, medium-sized cluster. So which contains 4 servers. Okay, for 10 minutes you did not do anything. The clusters are actually turned off. That means they're suspended actually in the backend. When you run like different queries, select star from EMP, do you think the same servers backend they're going to assign? Do you think the same servers you're going to get, same servers are going to execute your query, employee query?
No, no.
No way. No way at all. You're not sure, even AWS people also not sure which resources from which region or which data center they're going to pick up this. Wherever they're, I mean, they'll first check actually the free resources from the data center or from that resource or from that zone actually. They'll try to randomly allocate that resources to you. That's it. Now we don't want to do that in a client. We are dedicatedly create that resources in our private network, and we wanted to use only those services, only those servers. See, within a public, we are actually achieving private kind of cloud here indirectly. Are you getting?
But
Is
why?
getting?
What's the use of that? Why the people are bothering about which computing
Yes.
is allocating for them? If it is not
Let
that
me tell you.
much.
See, computing is nothing but execution engines, right? First, they will take the data from the database and they have to take the data into that server and they have to process that server actually. That means from the database layer to compute layer, the data will be transferred, right? Since they are public actually, somebody can come and hack the data which is there in the hardware, right? Your data is processed by public systems, right? Public systems means public RAMs, right? Somebody can come and hack the data, right? That is the reason why they'll try to create dedicated servers in that public private range or private network. They will try to use only those servers here to execute my queries, to process my data. Then what will happen? There is no chance of entering other people into this network. Then my data is secure.
Okay.
I'm in the public cloud only. I created services within public cloud only, but execution engines I'm taking from the private. Storage also private only.
Okay.
So that nobody can enter into this range except my organization. Getting my point?
Yeah, one more layer of security is added.
We are just
But-
adding one more layer of security. That's
There
it.
is no guarantee of, I understood what you are saying, but I don't think there is a guarantee. There is a guarantee of nobody can hack it. There are so many other ways to hack it, but yes,
See,
one layer
if you
we are
get into
putting,
that
one
one,
more
it's a big
shield.
topic again.
Yeah, I got you. Yeah, we are adding one more security layer kind of,
That's it.
shield.
See, if they don't provide that guarantee to us, why should I share that data? Why should I put my data in the cloud? Why I have to store the data? See, that they have to take care. See, that is what the guarantee, that is what the a service level agreement they made with me. Then I have to believe them. That's it.
Yeah.
They strongly told me when before I made the SLA with them, they strongly told me your data is secured like in this way. We are using these many security layers or these many keys, encryptions, and we are maintaining these security mechanisms and all. They have to demonstrate everything to me. I should believe them. Then only I'll go and store that.
Yeah.
Otherwise,
Yeah.
I'll not store my data in the public. See, hackers are always there. Hackers are always there to even they can hack from the private cloud also.
Yeah. 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 That's true.
See, wherever good is there, bad is also there. Agree?
Yes.
Whatever the way good you do, hackers will make it as will find out a loophole in that good, and they'll try to get into that network. That is always there. No system is perfect in the world. People always try to find out the loopholes. No system is perfect. No programmer is perfect. Okay.
Yeah. If they are perfect, there will be no more jobs.
Of course.
we don't find any jobs in the market if everybody is perfect.
Yes.
That is advantage for people like us.
Yes. Yeah. I'll just high level idea, guys. Here tomorrow we'll start actually these things actually, because I don't want to waste the time here. Okay. Now what I'm trying to say, the first component in the cloud that I'm going to discuss is the first object that I'm going to discuss here is data center. What is data center actually? What is this data center? Data center is nothing but it's a physical building. That's it. Where you have all these servers are equipped or arranged in a proper format, I can say. Okay, Azure data center. Onwards, I'm trying to start here Azure concepts case. That is the reason why I'll use the terminology Azure here. Azure data centers or AWS data centers are unique physical buildings. It's a physical building. That's it. Inside that building, they have servers inside that one. That's it. And they located across the globe actually, not in one place. They don't have they don't maintain all the data centers in a specific country. I'll tell you the reason also for that. Okay, so all those systems are connected each other, I can say. All the systems in the data centers connected each other. They can talk each other actually. They're connected via network, I can say. Okay. So Microsoft has more than 200 data centers across the globe, guys. Across the globe. This is recent count only. I mean, last 6 months back, or like 8 to 10 months back, I prepared this slide. I took this count from the official documentation only, official Microsoft documentation. I don't know if this count would have increased by this time, but at that time, this was actually 200 plus. Maybe they could have increased anyway. 200 plus means like 300 is also comes on to 200 plus only. You guys have to agree with that, of course. Okay, so they have 200 plus data centers across the globe. Okay, let me show you in which places they have that data centers and how they're interconnected in the back end. Let me try to show that actually. Okay. See, this is the official documentation, guys. I'm just showing you. You'll feel really good actually here. This is the see, this is the physical locations actually. Let me show you the India location. I think this map is India only, right? India, na? Sorry. not India. I'll go to India now, India location. Yeah, this is the India one, right? This is Sri Lanka, this is India, this is China, this is Russia. Yeah, this is India. In India, Azure actually maintaining three major regions: Central India, South India, and South India Central and South India. There are mainly three regions are there: Central India, South India, and this South India Central. Okay, these are all. See, you can see the data is flowing across the data centers here, between the data centers or among the data centers. Microsoft has the biggest infrastructure over the in the world actually. Uh, uh, Biggest interconnected infrastructure, I can say. Okay, see, all these data centers are talking to each other. All these physical buildings are indirectly talking to each other. See, you name any place here, they'll show you the data center location. See, they'll not give you exact address of the data center, guys, because it's again a security issue. They'll not give you, hey, your data center is located in so and so Hyderabad location, so and so Amirpet location, in so and so building. They will not give you that address. They will say that we have a location, we have a data center in Hyderabad. That's it. And they will not reveal that address and all. Okay, see here, some other country, Europe also, you have many data centers here. Even in the US also, you have many data centers. I don't know which. Saudi in the Western countries also you have that one. Even India also you have. Even in the US also you have. I don't know which country it is here. China. China also you have some data centers. Even Malaysia also we have some data centers. And if you go a little bit beyond this one, even in the Australia also we have some data centers. Even in the Mexico also, this is US region. In US also, this is US region actually, this border. Okay, here also we have some central US is there, West US is there, Bay Area. Okay, and California side. Okay, and here also we have some data centers. Here also we have some data centers. Here also some data centers. Okay, like that, data centers are like spread across the globe, I can say. Okay, they have 200 plus data centers across the globe. Okay, so the data center looks like this actually. It's a physical building. Okay, inside the building, it looks like this. All these are systems, case servers, I can say. System is nothing but a server with high configuration. Server is nothing but it's a system with high configuration. It's not like our laptop configuration, like 32 GB RAM or i5 processor with only 4 cores or 8 cores. It's not like that. So server is nothing but a high-end configuration. Okay, all these are servers. We call them as racks actually. I'll talk about the racks and all tomorrow, not now. All these servers are arranged in a boxes, I can say. I'll tell you what these boxes are called, how they're interconnected, what they're going to maintain and all. Okay, at high level, this is a physical building. So you know what are these things? On top of building, you have cooling systems actually. These are all AC like machines, I can say. In a data center, they have to maintain this cooling system. They have to maintain because ultimately, eventually, they are the electronic devices. Every electronic device actually dissipates some energy in the form of heat. If they don't maintain these cooling fans and systems, your systems will hang. You could have experienced even in your case also. If your laptop is too much dissipating too much of heat, right, your laptop will hang. Have you ever faced that kind of issue? Have
Many
you ever faced
times.
that kind of issue? Many times, of
Many
course.
times.
Your laptop will hang. So they have to maintain that cooling fans. They have to take out that heat from that building actually, and they have to maintain the power supply as well here. Okay, everything. Okay, at high level, this is just a building. Inside that one, it looks like this. This is nothing but a data center. Okay.
Yeah, they will maintain multiple power supplies. Like they will take two different
I'll
power
talk about
supplies
that one
from.
tomorrow. I'll
Yeah.
talk. See, I have that concept as well. Tomorrow I'll talk about that one. Okay, just have an idea, high level. Data center is nothing but a building. It's a physical building. That's it. Yeah, that's all, guys, for today. Yeah. Any questions you can ask if you have.
Then again, we need the manpower, right, Shiva, to maintain this data center.
The cloud people will maintain that one. I'm not going to do that one, right? I'm the
Okay,
business. See, I started my business. See, what did I do? I'm actually teaching. I'm running an institute. Consider. Okay. I don't need to set up the cloud and all right from my end to store my data. See, just now today only I've taken the official license from the cloud, official Microsoft license for taking these teams and everything, right? See, I don't need to concentrate on building the teams kind of application and maintaining that in the backend server and maintaining the cooling fans and maintaining the team. I don't need to think about that one, right? I just purchase that one. Every month I need to pay rent at $12 for them. I'm just using their application from my end. That's it. So that my business will run smoothly.
I would like to give an example. So, say for example, people like want to practice some big data kind of a thing. We cannot really have, if you are not working, if you want to personally learn big data kind of a thing, of course, we may not be enough offered to have all those systems.
Yeah.
So there are some providers. So one of the example is CloudX Lab.
Cloud.
So you can
Cloudera.
go Cloudera. CloudX Lab is a place
Yeah,
where
I know.
you can go and pay subscription for 6 months or 1 year, and they will give you this many instances. So we can make use of it. So we don't need to maintain anything.
Yes.
It's again
Even
like a cloud.
IT University as well.
Yes.
Yeah, they're also providing the same way. You just need to create an account with them, and they have installed everything: big data, Hive, Pig, and the Scoop, Spark, all the versions that 2.x, 3.x, everything they install. HBase also, everything they are maintaining in the backend. You just need to create an account and start using them. That's it. Long back, to demonstrate Hadoop environment to one of the college students, I've taken the IT University subscription. At that time, I've shown them what exactly cluster is and what will happen when you try to store the data back and how it is splitting the data when you upload some data to it. Okay, what is partition? I was able to show them in a very good way by creating the class. By taking their subscription. So
I remember CloudX, they give 6 instance or 6
I
to
think
8
4 or
instance
6
node.
instances.
Yeah.
Yeah.
And
Yeah.
it is cheaper.
Yeah, cheaper.
Yeah.
IT University, they are providing 4 systems actually. 4 cluster node actually. 4 node cluster, I can say, and you can use them whatever way you want. Okay, one is master node and remaining are like a worker nodes actually. Okay. Yeah.
So the simple example is if we take that pizza example, right? So that's our
Pizza
choice.
example.
Whether we wanted to eat at we wanted to make it home and eat at home, or we wanted to
everything.
order the pizza and eat at home, or we wanted to go at restaurant and eat at home,
Yes.
eat at that place. So that is a simple example for it.
Yes.
That's our choice whether we wanted to
Yeah.
we wanted to eat.
What service you wanted to take from them, that's your choice. How much help you are taking, based on that you need to pay extra cost for them.
See, it's
Because
an
they're helping
example.
you.
The same example. If you are going and collecting, there will be a price. If there is a home delivery, there is a price.
Fine.
Yes, of
Yeah.
course.
If you
See,
go to the restaurant,
of
that
course.
is different.
Okay. Mm. Any other thing, guys? See, this week, whole week, actually, I'm going to discuss the theory concepts only. But do not think that I'm boring you guys, and do not think that these are waste topics. No, no, please, because these are required to understand the next topics. Actually, I mean, while spinning up the services, these are not junk topics. If they are junk topics, I could have cut these topics, because I don't want to waste your time. I don't want to waste my time as well. Okay, these are important. I wanted to give you full clarity what is cloud.
Shiva, still I have a doubt on that one, Shiva. These
Which
data
one?
centers, like Microsoft people has to maintain, right? Physically,
Yes.
people required,
Yes,
right?
yes. Yeah, yeah.
Okay. Understood. Because before
Microsoft
each
will
and every
maintain, yes.
company,
Mm.
yeah,
Mm.
before that, each and every company has to maintain the servers and cooling systems and all manpower. Now they are just leave it to the cloud people. So they are maintaining data
Yes.
centers and they are maintaining the people, right?
Yes, yes. For that, they are
Okay.
charging, they're taking rent from
Yeah,
us.
yeah, each and every company has to pay some rent for what the
See, based
services they
on
are
their
using.
maintenance rate, they'll
Service.
charge.
Okay, understood.
Nowadays, this hardware has become very cheap, guys. So slowly, year by year, the infrastructure cost is getting reduced. At some point of time, cloud also will become very cheap. Maybe after a few years. Okay. That
So
storage
like in
is dead
future,
cheap.
is there any chance that physical applications also become like cloud applications, like Power BI desktop is there, like Tableau, there are physical applications, right? We need to download it and run. So
But
in future,
ultimately,
they also,
you're publishing them to the cloud only, right? Again.
yes, we have to publish in the cloud.
You're publishing that one, right? So that is also cloud,
Yes.
right? Again.
So it's already started. If you take Informatica, earlier it was Power Center. Now it
Power
is
Center.
IACS, Informatica Cloud.
IACS. Yes. Yes. That is also private cloud example only. I can say public cloud, not private cloud. Anybody can create the account with Informatica, right? And they can start. But they're storing actually in their data centers only Informatica data. That's it. No other services they're providing. Public cloud with limited options. That's it. Informatica. Yeah, that's all, guys.
Any product, if they want to survive in the market, no other choice. They have to move towards cloud.
Cloud. Mm. Okay. That's all, guys. Thank you. Thanks for your time. Tomorrow we'll meet again. Same time. Okay. At same time. Thank you. Thanks for your time. Have a nice day. Take care. Bye.
Okay. Bye.
Thank you.